So what we want to do in this lesson is transform formulas, and it can be quite confusing. So what I like to do is think of it as the old fact families that you probably did in elementary school. So looking at this fact triangle, it's an addition, subtraction fact triangle. It's got 8, 2, and 6. I know that 2 plus 6 will equal 8. Pretty easy, right? And we know another addition fact from this is that 6 plus 2 equals 8. Well, if we wanted to solve this for, let's say, 2, we want to have 2 all alone. We know that 8 minus 6 equals 2. Another way to think of it is, if I had 6 plus 2 equals 8, and I wanted to get 2 all alone, I'm going to put 2 in a box here, I would have to subtract 6. And 2 on this side, 8 minus 6 on this side. So 8 minus 6 we know equals 2. And you might be thinking, well, yeah, I know this is nothing, okay? And you know that the other subtraction part would be 8 minus 2 equals 6. And you might be thinking, well, I've got that. I know numbers. Well, here's what happens. We can think of it the same way if we had a fact triangle with adding and subtracting. But this time, let's pretend that instead of having numbers in our fact triangle, we have letters. We have the letter M here, and we have the letter R here, and we have the letter T here. Well, by adding, we know the two parts, R plus T, have to equal M. And you might be saying, well, what's R, what's T, what's M? It doesn't matter, because what we're trying to do is figure out a way to transform the formula. So another addition sentence, we know that since addition is commutative, we could do T plus R to equal M. And if we needed to make a subtraction sentence, let's see. We know that let's pretend I wanted to solve for R this time. I could subtract a T on both sides. Well, now this says M minus T equals R. And we also know that M minus R would equal T. And again, you might be confused. You might be saying, well, that doesn't make sense. Well, another way to think of it is if we look at these, we want to transform these formulas to solve for the variable indicated in red. Okay? So the S is in red. I'm going to put the S in a box. I'm going to cut down the equal sign. Solve for the variable indicated in red. We need to get S all alone. You might be thinking, well, what is S? It doesn't matter. We're not going to get a number for S. We're not going to get a number for P or for C. What we want to do is just get the letter S all alone. And we do this the same way we've been solving multi-step equations. First we look for the distributive property, there is none. Then we combine like terms, there are none. Then we undo then we undo addition and subtraction. They subtracted C. We don't know what C is. We do know that it was subtracted. We need to do the inverse. We're going to add C. On this side, the left will have P plus C, and that will equal S. We have now solved for S. What that means is we have S all alone on one side of the equation. S is equal to P plus C. We don't know what number could take the place of P or C or S, and in fact we really don't care. What we wanted to do was solve for that letter. Get the letter S all alone, which we did. We're going to do the same thing in the next one. They want us to solve for K. We need to get the letter K all alone. So again, we follow our steps for multi-step equations. First we look for distributive property. Since there is none, we look for like terms to combine. There are none of those. Next we undo addition and subtraction, and there is none of that. So the last thing is undo multiplication and division. We know that this line underneath the K is a division symbol. So we're going to do the inverse. We're going to multiply by J. On the left side it now says H times J, which I'm just going to write as HJ. Or you can write 8 times J like that. Equals, we know the J's will cancel. K is all alone. We're done. It looks confusing because we want to see real numbers, but we don't have numbers for H or J or K. This is all we've got. We got K all alone, which is what the directions said to do. Solve for the variable in red. In letter C, it's a little trickier. Again, we want to get the letter P all alone. Okay, that's the variable in red. So there's a couple ways we can do this. We know that it started as I equals P times R times T. And we want to get this letter P all alone. So one thing that some people like to do is they say, well, I know R times T is RT. That's considered one term. So I'm just going to come along and divide the whole thing by RT. And I got to do that on both sides. And this is totally acceptable. I divided by RT, we know the R and the T would cancel here, equals P. We are done. You can stop right there. Other people might look at that one and say, well, I want to do it a little differently. It started with I equals P times R times T. I know I have to get the letter P all alone. So some people say, I'm going to first divide by R. So now it says I divided by R equals P times T. And then some people come along and say, now I'm going to divide by T. So it says I divided by R divided by T equals P. Again, that gets the letter P all alone. Now you'll notice it says solve by substituting your own numbers. That's one way you can check that you transformed the formula correctly. So if we go back to letter A, it started with P equals S minus C. I get to pick numbers to put in here to make this a true statement, just because I'm trying to check to make sure that I rearranged or transformed my formula correctly. So if I want S to be the number 11 and I want C to be the number 4, I know 11 minus 4 would be 7. I know P would have to be 7. So that's the beginning formula. When I transformed the formula, I got this, P plus C equals S. So P plus C equals S, when it's transformed, again, I'm going to use the same numbers. I said I want the letter P to stand for 7, I want C to stand for 4, S to stand for 11. I want to see if this is a true statement. On the left side, 7 plus 4, P plus C, 7 plus 4, 11, S equals 11. It worked. And that would work on all the other ones also. If you transform correctly, when you substitute numbers in for your letters, you should get true mathematical statements. They get a little tougher now. We're going to cross off letter D. We don't need to worry about that one right now. But when we look at letter A, again, we need to follow the 4 steps of a multi-step equation. I know way back when we started 2-step equations, some kids like to find the variable that they're solving for and anything attached to it, in this case A, and anything attached to it, and put it in a box. That was their way of saying, I can't break that apart until the end. And if that's something you'd like to do, that's fine. Multi-step equations, first we look for distributive property. I don't see any. Second, we combine like terms. Don't see any of that. Third, we're going to undo addition and subtraction. I see addition, they added 7, we have to subtract 7. The plus 7 and the minus 7 turn into 0. On the right side it says b minus 7, so that's exactly what we have to write down, is b minus 7. And on the left side we have 5a. So the first thing we looked for was distributive property, then combining like terms, undo addition and subtraction. Last we have to undo multiplication and division. There's a 5 next to an a, that means 5 times a, so we're going to come along and divide by 5. Now we have to divide the whole side by 5. The whole right side gets divided by 5. On the left, the 5's cancel. They turn into 1, 1a, which is good. We got a all alone. And on the right side it says b minus 7, all divided by 5. We need a big fraction bar to say the b minus 7 is one term. And that's the term that we got from the earlier step of doing b minus 7. Another way you could write this, still have a, but we could do this. b minus 7 was from the first part of solving this equation. So we put it in parentheses, and then we say, I want to divide all that by 5. That is another way that you could write that answer. So when we move on to the letter B, we're going to do things the same way. In letter B, we want to solve for W, and there's a 2 attached to it, so I'm going to put that in a box. I know that they did addition, and I want to get rid of this 2L, that's a cursive L, so I'm going to subtract 2L, subtract 2L. So now on the left side it says P minus 2L, and that will equal 2W. Next, I want to get W all alone. They did 2 times W, so I'm going to divide by 2. Again, like before on letter A, example A, we want to divide the whole thing. So a big fraction bar to show division. The 2's cancel on the right. I know I have W all alone. And on the left side, I have P minus 2L, all divided by 2. This is one great way to write that answer. There are other ways to write that answer. One way is to put the P minus 2L in parentheses and say I'm going to divide by 2, and that equals W. And one more way, which is a little tricky, if I wanted to simplify this first way of writing my answer, if I'm going to divide by 2, I have to divide each term by 2. So what that would say is the letter P is divided by 2. P divided by 2. Then the minus sign. Next I have 2L divided by 2. Well, the 2's would cancel, so I'd just be left with 1L equals W. This is a little more confusing, but it is definitely mathematically correct. And then letter C on here. Again, we'd look for distributive property. I don't see any. Combine like terms, none of those. Undo addition and subtraction. I would subtract 8. On the left side it says y minus 8. On the right side I'm left with x over 3. X over 3 means x divided by 3. So I'm going to come along and multiply by 3 on both sides. 3's cancel. I have x all alone now. So I've got y minus 8. And I need to say that whole piece, the y minus 8, the whole thing is times 3. So one way to write it is put the y minus 8 in parentheses like I did and say that's times 3. You could simplify that by distributing the 3. So the 3 would distribute to the y, 3y, minus, and then the 3 distributes to the 8, 24. And all that equals x also. So that's another way we could write that one. Again, it says check by substitution. You could substitute numbers. If you transformed correctly, which I believe we did, we would get mathematical proof. All right, another one. Here's our formula. P equals 750 plus 150H. We'd look for distributive property. Since there isn't any, we would look to combine like terms. There's none of that. We would undo addition and subtraction. Notice it says solve this for H. So I'm going to put that in a box. I would subtract 750. On the left side it says P minus 7.5 or 7.50 equals, on the right side I got 1.50H. Next up, I need to get H all alone, so I'm going to divide by 1.50. Divide by 1.50, cancels on this side. H is now all alone. P minus 7.50, all divided by 1.50, a big fraction bar. All that equals H. Now, similar to the last problems we had, we could write that answer a few different ways. We still have the P minus 750, but I could put that in parentheses and say I'm going to divide it by 150, and that equals H. That's another good way. And we could divide each piece. We could go back here and take the letter P and divide it by 150, which looks a little funny. P divided by 150, subtraction sign. Then we'd have to do the 750 divided by 150, which is 5, and that would equal H. A little bit tricky, but that's mathematically correct. Last one in here. If you had $13.50 to spend, the first thing you'd have to do in this problem, you get to Waterworld, it says you have to pay your admission fee of $7.50. So I just spent $7.50. I am left with $6. Now I want to rent a tube, and it says tubes are $1.50 an hour. So I'm going to take the $6 and divide it by the $1.50. Moving decimals to divide. I know 150 fits into 600 4 times. I could rent a tube for 4 hours with my leftover money. Transforming formulas can be a little bit difficult. If you're careful and you think of all the steps of solving a multi-step equation, it can go a little better for you. Good luck.